Okay, welcome. My name is Teemu Tapanila, and I'm Microsoft student partner, and I'm here to tell you about Kinect and mainly about the Windows SDK. How many of you haven't ever heard of Kinect? Raise your hand. Okay. So, what's Kinect? It's a new Microsoft device, and it's look black, and it says really nothing. But really, it's a very cool device. It has a camera in the middle. It's a normal VGA quality and 30 frames per second. It has two 3D depth sensors, which works with infrared. Also, it has multi-array microphones. There's 4 microphones there, and the sound quality is very good. Also, it has motorized tilt, so you can like tilt it depending on where it is. So it's very cool. Yeah. So the Kinect SDK provides 4 kind of data: the image data, which is of course just the image; then the depth data, which is like how far from the device things are; and the skeleton data, if there's any skeletons present, like humans, of course, it will provide some data from those. Also, it has very good sound data, which contains the sound and then the direction of the sound. There's a limitation with the depth. For best performance, it should be 1.2 meters from the device. This might change when like time goes on, but currently these are the preparations. The skeleton tracking contains joints, and there's 20 joints on human, and if every joint doesn't need to be visible to the Kinect itself. If the skeleton is visible from shoulders to knees, it can track it, but it prefers a full skeleton. So you cannot, it doesn't detect you if you're sitting or like laying down. So you need to stay up. Also, currently there is like limitation that it can track 6 people. And 6 people is a distance, like how far from the device they are. And then 2 people are full skeleton. So currently you can only get 2 full skeletons, but 6 distances. That's the current limitation. It might change, at least hopefully. The sound data. Currently, the direction of the sound is very good. I mean, it can tell you the angle where you are speaking from the device. So you can easily use that data for something. Also, the sound, because of the 4 microphones, it's very good. The requirements for developing with this is, of course, you need a sensor. Also, when you are trying to get the sensor, don't buy the Xbox 360 plus Kinect bundle, because you need a special power cable to get it connected to your computer. And that's only included on the Kinect standalone package. If you get the bundle with Xbox, you need to buy the power cable from somewhere. It might be a bit hard to get. But also, you need the Windows 7. It doesn't support anything else. And Visual Studio 2010. Any version is OK, but you need the Visual Studio 2010. The Express version is free. And of course, you need the SDK itself. And that's it. You're ready to go. Of course, if you want to do some 3D drawing or something like that, you need DirectX. So let's go to the demo. And Drazen, can you come here? When you are coding for Kinect, it helps you a lot if you have someone else than you to play with the Kinect, because often you have to stop the Kinect and start again. Of course, it might be a little boring for the other guy to just waving hands and stuff like that, but it's a lot better. So this is Visual Studio. I'm just going to create a new project. And the first thing is that I will add the references for the SDK. They are normally at here.net, but because I have used those, they are at here. And I will change the grid to canvas. Because it will be a lot easier to draw things on the canvas. Oh yeah, there's. Yeah. With the capital. Yeah. Now, what I will do, instead of printing just hello world, I will do that you will see your own hand moving around the screen. I will not draw the hand. I will just draw a circle where your hand is. So first, we start with with including the Kinect SDK. There's two parts in the SDK. The natural user interface, which provides the skeletal tracking, depth data, image data, the camera data. And then there's the sound part, which provides, of course, the sound information. So first, I'm creating the Kinect runtime, and I will initialize it. When you initialize the runtime, it will ask you like which features you want. You can turn all of this on. But if you do so, it will stress your computer more. So it's preferred to just use those which you want. The color, it's of course the image. The depth, it's only the depth data. Depth and player index is depth data plus player index. It will try to figure out, like when someone enters to the field of Kinect, it will give him idea. And when someone else enters, he will get a new idea. It will also try to keep the idea intact. But of course, if someone goes out of the field and then comes back, it doesn't keep that. The Xbox SDK, it uses facial recognition to keep the idea intact. And there will be something coming here. But currently, that works only if you stay on the field vision of the Kinect. I will now use the skeletal tracking. And here is a skeleton frame ready event. So when it has received full skeleton, it will rise the event, and then you can handle it. But it won't do that if there is no skeleton present. It contains the collection of skeletons Also, there is quality, like if you want to know what is the quality of the camera currently. And also normal to gravity. It knows like how far from ground it is. But I will use the skeletons, and I will loop through all of the skeletons. So each skeleton got the joints, which is all of the 20 joints. It also has the position. The position is your mass center, and it's calculated from there. Then there is a quality. The quality, there is 4 status. Bottom, which means it doesn't see your bottom. It doesn't see your left, it doesn't see to your right, it doesn't see your top. So if you're interested that only the full skeletons are analyzed, then you should use that it's not clipped on any state. But I'm interested that the tracking state is tracked. So it will only give me the skeletons, which has the full skeleton data. I'm not interested in people that are just standing there somewhere. Of course, in this case, everyone who is like tracked have their skeleton data because there's only one people there. But if like more people were running behind him, then this would be very smart. Okay. Now I got the joint collection, which has each of these joints, and I will use the hand right. And there is position, which has X, U, and Z. Also the W. X is of course your like from this side, and U is on the height. Z is the distance. W is the change, so like how much it has changed since last time. The position gives values between -1 and +1 on X, U, and Z. Oh, no, only X and U. Z is like the distance, so it's always correct. But the X and U, if you want to use those as coordinates in your screen, you need to scale those. The scaling itself is a bit harder, but there is already a toolkit for it, and the scaling will be included in Kinect SDK in some point. But currently, just download the toolkit. So I will add the toolkit to my references. It's called Coding for Fun Kinect WebAF Toolkit. And it will ask me to what resolution I want to scale it. Also, it will ask me, there is 2 options. It will ask me max skeleton, X and U. That is because the distance does affect the X and U positions. So if your application doesn't like tell people like how far to stand, you need to use this to calculate like how much you want to use. So I will use 800 x 800. I think, yeah, about that. Now I will also set the resolution of my application to that. Yeah. So now I will create ellipse. I will use the ellipse to show you the position of the right hand and only the right hand. Also, you need to add the name to the canvas, because normally it doesn't have name. I will call it the canvas. Okay. So now I have the ellipse ready, and it will be drawn on the screen. Now, when you're moving your hand, I want to just like move the ellipse around. So I will just use the marking. Okay. Yeah. Yeah, it's a little big for this resolution. I will change it to 600. Okay. Now, Troyson. Yeah. So it will show the moving of the hand right. And currently, this is the hello world. It's drawing your hand. Woohoo! It's a bit much code to just draw one hand. But of course, you can do everything else with it. Also, because of the lightning, for the Kinect to run very well, you need just very good lighting and prefer not big shadows. And currently, if you're like waving your hand this way, yeah, it's jumping a little, kind of much. There is a smoothing parameters which you can use, so it will calculate more softer and smoother curve. And also, it's just like if you want to do a very good calculation, you need to remove interference. There's a small interference, and they are going to add that to the final SDK in some point, but currently it's like just to toy with and build the prototypes. So it's not a final, it's a beta. So this is a hello world. Now a little more complex example. I will draw ellipses on every joint of the body, so you will see the full body. And I will just create a few functions. So it had 20 joints. So I will create 20 ellipses. And just add them to the list. And in here, I will go through all of the joints. And I will scale each one. To same resolution. So these values are different depending on how far away your target is, and of course about your resolution. Also, you can make it that way that you can only move like on the right corner, right upper corner, or right down corner, or something like that. So you don't need to use the full application resolution if you want to like have just part of your application working with the Kinect. But yeah. So yeah, I'm just going to loop through the full list and each of the joints and just give them a value. So yeah. Okay, now if I did everything right. Okay. Okay, I didn't. Wee. Yeah, I didn't add them to the list, so that's why it's not working. Yeah. No. Yeah. Because of the scaling, it was OK for one hand and that distance. But if you want to use the full body, that scaling is no good. So I will just lower it. And when you try stuff, the scaling is a very important part. And you should always try different kind of scaling. Because without the scaling, you need to wave your hand way more, a lot. Oh yeah, sorry, I made it even bigger. Wrong direction. Yeah. So now, currently the Kinect is aimed kind of high, so it doesn't see your feet so well. That's why they're like down there. And also there's like kind of a lot of interference because I think these are the leg balls here, and because it doesn't see your leg, they are very interfered. So it's like throwing them somewhere. So I will show you how to use the Kinect tilt. After you have initialized the runtime, you can just tilt it. Oh, no. Where it was. Yeah, here. So now it did move a bit. So now it sees your legs better. And you shouldn't use the tilt function a lot because it will stress out the tilt motor. And so the basic idea is to calibrate Kinect once per location. Like when you install it at your home, you calibrate it once and that's it. Of course, if there's problems, you calibrate it again. But don't use that very often because it will break out. And also, you cannot use it very fast. The driver won't allow you to because it just will break out. But yeah, this is the skeleton demo. And as you can see, all of the joints that were in the picture are now here. And with this, I can get the position of each of your like legs, shoulders, and stuff like that. And I could use it for the coding. So what I'm going to do now is add a button to this application. And when you are holding your hand over a button and pushing, like it's natural when you are like pushing a button, it will really send the push event to the application. Yeah. Also, when you do this kind of interface, remember that Kinect is not a very, even if you're like holding your stand, it's not a still. So make big buttons. And also, when you look at games or something that's already done, there is a little homing on the icons. So if you go near it, it will like move you to it. And also, it doesn't register small movement of your hand when you're controlling it. But I'm just going to do this with a big button. Yeah, I think it's big enough. So I will add a float that is last distance. So when you have like entered your hand on the button, and when you push it, then it will like register the pushing. For that, I will need to store the distance when you have entered on the area of button. And if you have like gone closer than that, at the next time that you're in the area, I will do it, count it as a pushing, and it will be a click. There is a lot of ways to do gesture recognition and stuff like that, but they're a bit complex, and I will not go through them, but there's a lot of examples on the internet about those. So, okay. I will let it draw the full skeleton, but I will just focus on the right hand, because I think it's very natural to use stuff with right hand. Of course, if you are left-handed, it's more natural to use left hand. So I will just calculate the position of the right hand. I will use the same scaling as with the skeleton, so it doesn't look stupid. And I will just check if your axe is over the button 1. So this will check that your hand is over the left hand and the right side of the button. So yeah. Also for the U coordinate. Okay. So there's checking for that your hand is on the area. Now I will initialize the distance. I will multiply it with 10, because then it will be easier to calculate more minor change in the distance. So if the last distance minus new distance is bigger than 1, it will think that this is a click event. I will now create a click event itself. Okay. So when you click it, it will do the hello world. Oh. Yeah, forgot. So I will first click it myself. Now you see it's hello world. And now, if you raise your right hand, yeah. And now push it. Because of the scaling, it's currently not big enough. Or try it again. Yeah. Yeah, I'm probably doing something wrong. Let me check. Yeah, it's a position U. It should be Z. That might help it a lot. Okay. Yeah.
The margin, should the other one be left and the other one right? You have both left now. Also
I do.
the top, a little higher. Button 1.margin.left.
Button 1.margin.left. Yeah. Yeah. Also, when you are like debugging stuff, if it doesn't seem to work like this, I will just like print stuff on the screen. Or if you are like thinking it's not that, then you can just like play it around, and it should help. Yeah. Yeah. Wait a second. Position axis more bigger than marking left. Position. Yeah. Yeah. Because there's something wrong, I will do it a bit easier way.
The first two pairs should be left and right, and then top and bottom. Now you have left and
Yeah.
left.
Yeah.
I mean, there's a.
It is? Wow.
If position X is more than left and less than left, it should be probably
Less than. Yeah, it's plus width. And from here, if U is bigger than from top, and U is smaller than top plus height, yeah, that should be correct. Yeah. Yeah, I make mistakes. Everyone does. But for some reason, is the scaling right? Yeah. Yeah, very strange thing. Anyway, I will undo that and do it easier way. So instead of checking if you're inside box, I will just check if you like pushing your hand. Yeah, I think it's wrong on here. I think, yeah. That's probably it. Yeah, because he moved forward, it's just now sending a lot of hello worlds. Yay, it works on that solution. But so, if you're like stuck in something like this, it's a lot easier to just print stuff out. But because I'm soon running out of time, I won't be doing the printing. Now is the time for questions. Does anyone have a question? Anything? Also, it's not only a C#. You can also write with C++, and it's even a bit better with C++. You get more access to the raw data if you want to calculate yourself, and you feel that Microsoft is not doing so well on finding the skeleton. You can do it yourself. I mean, there's a lot of good examples of doing it yourself, but I don't know, I don't like to do it myself. It's a lot easier to just rely on the SDK because it's getting better and better with stuff like that. So also, yeah.
You have this limitation of 1.2 meters. You can't get closer than that. Is that because of the focus, or is it the skeletal algorithm?
Yeah, so the question was about the limitation of 1.2 meters. The limitation is currently on driver plus software. There's open source libraries that can see your hand from this distance. So it's just something to do with the driver and software. But they were like, I think also it's not so good at that distance. The perfect distance for depth data is 0.6 meters. And that's the perfect optimization for just the depth data. Yep.
Could this be used for scanning 3D objects?
Yeah, so could this be used on what's stunning?
Scanning, so I can make a movie with scanning faces or...
Okay, so the question was, could you use this for the scanning 3D object? Yeah. I think there is already 3D Max plugin for this from IPsoft, I think. And I haven't tried it, but people have said that it's okay. I mean, the Kinect is not like very, very accurate. But if you just want to do something, yeah, of course. Because it points all of your joints. So if you're like moving around, your 3D model will move around. And there is currently, I haven't seen any example with a 3D skeleton. And I haven't done myself because I don't know how to do 3D skeleton. So if you want to do 3D skeleton, I can do the Kinect code for you. OK? So any other questions? Yep.
You said it supports C++. Does it mean native C++ or managed?
Manage. So any other questions? OK. If not, then thank you.